In this video, we'll look at A16 of Science Paper 1 2022. The question reads, the diagram shows a circuit containing two resistors in parallel while one is in series with the two. The EMF from the battery is 20 volts. Find the reading of the ammeter when the switch is open and when it is closed. Now you should know that an ammeter is an instrument that is used to read current. And then next, you should know the resistors that are connected in parallel and the resistors that are connected in series. In the other one that is connected in series with the other two. So the resistors in parallel are these ones. The 2 ohms, this other 2 ohms. And then that is connected in series with these two is obviously the remaining one, which is the 3 ohms. Next, you should know how to calculate the resistance in parallel to the resistance in series and also current. Now, to make this calculation or this question easy for us, we can first give or denote these resistors as R1, R2, and R3, just to make things simpler for us. So now, to calculate when you're calculating the ammeter reading, which is the current for when the switch is open, is that you're only going to consider R1 and R2. Why? Because when this switch is open, R1 and R3 behave as if they're the only ones in series, because this R2 will not work, only these two are going to work. And then the resistance, or when calculating the ammeter reading, which is the current when the switch is closed, you're going to see 3 resistors because they're all working. So we can now do our calculations. So we've said first thing that this and this is R2 and this is R3. Next, we'll say for when the switch is open, we're supposed to calculate, so current is equals to I is equals to V over R, V being the volts that we've been given as TV, and then R we do not have. So we say that the total for when the switch is open is going to be equals to R1 plus R3. This is the formula for calculating resistance when it is in series. So will be equals to R1 is 3 ohms plus R2 is, so that means that R total will be equals to 5 ohms. Therefore, current will be equals to 20 volts divided by 5 ohms, and then current will be equals to 4 amps as the units for current. Next, when the switch is closed, you're going to have R total equals to over R2 plus 1 over R3. This is in brackets. So this formula that I've written in brackets is for resistance in parallel plus R1, because R1 is connected in series with both R2 and R3, which are in parallel. So we don't put it or we don't write it in reciprocal form, which is 1 over R1, because this one is in series with the other two. So therefore is equals to 1 over 2 ohms plus 1 over 2 ohms in brackets plus 3 ohms. And then R total will be equals to, since the common denominator here is 2, that means that we can say 1 plus 1 is 2. 2 divided by, so that what you're going to have is obviously we can just say, if you want, you can say 2 plus, that's 2 divided by, or let's just say 1 divided by 2 is plus another 0.5 plus 3 ohms. So if you can't do this, you can just say common denominator to 1 plus 1 is 2, 2 divided by 2 is 1, which is the same thing that we've done here. 1 divided by 2 is 0.5, 1 divided by 2 is 0.5 plus sign that you have here. So our total will be equals to 0.5 plus 0.5 is 1. So that's 1 ohms plus 3, and then 1 plus 3 is equal to 4 ohms. So this is our total resistance for when the switch is closed. And then our current now, current is going to I equals to, using this formula, this say that we wrote, so I is equals to the same 20 volts, which is 20 V divided by 4 ohms. This is going to give you a current of 5 amps as the ammeter reading. So when the switch is open, you will have 4 amps, and when the switch is closed, you're going to have 5 amps. Let's compare this with the options that we have. So on the options given, you realize to say our correct answer here will be C. And that's it for this question.